Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. In today's lesson, we're going to learn how to make upstream edits in the CATIA V5 specification tree. So we want to edit this part that we spoke about in our previous lesson. So we need to go to the differential and rear axle housing part, and you'll have to expand and double click on the parts. Just like that. And the first thing you want to make sure, let me hide this, we don't need the blueprints for now. When you're making adjustments to an upstream component, you want to make sure that the subsequent parts that you created afterwards are properly constrained such that they will move together with the part. For example, if I reduce this distance and this width, this distance here and this distance here, if I scale it down, I don't want for example, this attachment, this part that we created here, to remain in its position. I want it to move together with this initial component, and for it to do so, we need to make sure that the sketch of these subsequent parts have been constrained to the original element. That means if we had a rectangle here, we would have to maybe project a 3D element of this sketch and constrain them together. So that we don't have a lot of components here, so we can quickly go over them. For example, this is not very important because we remove this manually, but we are interested in this part here. Perhaps we can open this in a new window so that we don't have to deal with the chassis. So we have these two pads here that are mirrored. We also have this pad, and this shaft. So this shaft is obviously constrained to the holes here. So if we constrain the sketch of the holes, we also constrain the shafts. Let's start with this one because it was the first one that we created. So I'm going to expand the specification tree and go to the pad. That side is on the mirror side, so I will come to this side. This is the pad, and that is pad 6. So you need its sketch, which is sketch 10. Pad 5 and 6 are a result of sketch 10. I'm going to reframe on sketch 10. So what I'm saying is you need to make sure that when you move or when you resize this component, this part is also going to move with it, and you need to make sure they are properly constrained. I'm going to start by removing this perpendicular constraint right there, and instead I want it to be perpendicular to this line so that these lines are also parallel to this edge right here. And these two, instead of these two constraints, I'm going to delete them. Instead of the points, I'm going to constrain the line. So let's see how you can go about that. You can just select. We've got two constraints. I don't know if you can see them. If I move it like that, you can see we've got this edge and this edge. So I do want to make this line and this line perpendicular. And I want to make sure that that constraint is added. So right there. I can try to make this two not perpendicular. I wanted parallel, but that's okay. So these two are perpendicular. Now I can constrain this edge to this line, because when we move it, it is unstable. It can be here, it can move upstream, it can move downstream. We want to make sure that it remains in this relative position. So I can constrain it to the end of this edge. I can say the distance between this point and this edge is that. You don't have to change them, you just need to add the constraint. And the distance between this edge and this edge. Then you want to control the vertical positioning. So you can say the distance between this edge and this horizontal edge is 0. So that makes sure that when we make edits, this sketch will move relative to our geometry. You can also add the horizontal, but I think that is already governed. It will be over constrained. Oh, if you can add it, that's fine. So I exit. Now I'm sure that if I scale my model, this will move relative to its original position. Now let's go to the subsequent one. The next is this pad right here, which is pad 7. So we go to sketch 12. Now for sketch 12, we have projected this surface. We have this vertical line and we have this diagonal line. So we can constrain first this vertical line to be we can constrain it to this line as well. So we select, because we sketched this plane, okay? So we can say they are parallel like that. And you can also give it a dimension so that it remains the same. You can give it a dimension like that. You can delete this point. I have a point here, trying to delete it. We can delete that point. That looks constrained to me. Or even instead of this, you can still add the distance between the top and this point. But then again, when you add a constraint between the top and this point, remember it can be the distance below and the distance above. Like, it's not positive or negative. So perhaps the best way is to check the distance between the bottom side and the top part. So you can constrain this point to either this line or this edge instead of the top one, because the top one the sketch can go over. So I can say maybe between this and this. It's already over constrained, so I will delete that. Maybe I can leave it like that. If it misbehaves, then I can edit later on. Let's just leave it as it is. So that governs these two geometry. Third, we have the holes, the pocket. So you have to locate the pocket right here, and it's sketch 15. Sketch 15, we've got, where is it? The frame on? No, not that sketch. Not that pocket. We had to have some 2 holes on this geometry. If it's not pocket 2, it must be pocket 1. Let's see. So sketch 11. Yeah. So we've got 2 holes. They are not defined. So we want to make sure we add an axis between those 2 points. Perhaps I can make that axis and this edge to be parallel to each other. And I can also constrain the distance between the top edge and this axis to make sure that it moves with this geometry. So you want to make sure every subsequent sketch has a relationship with the previous geometries, okay? So that when you move the original geometry, the subsequent geometries are subjected to move and the features are retained in the perspective that you want. Lastly, we've got this pad 9. So we go to sketch 13, and I can already see we've got one point that is over constrained, so we might want to delete that. Now we've already set the distance between the horizontal axis and where this circle starts, so that will remain relative to that part. Perhaps you can leave it. We've got 2 constraints right here. I'm not sure which this one is. Doesn't seem relevant. I can delete that. Hold on, let me first check what we are constraining right there. Can double click on it, and it's between this point and the imported geometry. Okay. Then which is this? If that is between the point and the geometry, we might want to check this. No, just need the constraint. It's between the point and the intersection 2, the point and the face. Those two seem to be sort of the same. I can delete that. I just need this point to be coincident with this line. That's all I need. Okay, we can make edits later on if it misbehaves. For now, I feel like we have constrained the subsequent parts. Now for this geometry. So sketch 14. The first thing I think we made this too big, so perhaps we can make it 10 instead. The outer diameter is flexible. All we need to maintain is the inner diameter. The inner diameters are 15 millimeter in diameter. They are 40 millimeter apart, and we've set the distance between the vertical axis and its position. So we need to constrain its vertical direction, and I want it to move relative to, or maybe we can adjust that one later on. Let's just leave it. Let's leave it. All right. Now that we have tried to constrain our subsequent geometry to the original one, we can make some edits to the original one, which is very simple. We had 4 sketches. We had a sketch here, which was kind of a rounded rectangle. We had a circle. We had this profile and the side profile. So we will go to the multi-section solids, and we will just edit. So what I want to do is I want to reduce, we had 56 millimeter diameter on this side. I want to reduce it to 40 millimeter diameter. So that's a radius of 20. And I also want to reduce the distance between this point and the horizontal axis to 60 millimeters. So I will go to sketch 2. Let's start with sketch 2, and we say we are reducing this one to 20. That's the first one. And then I want the distance. So what I want to maintain, I want to be to make something clear. We've got some edge fillets at this section. I want to keep this section exactly the way it is. I don't want to move it or change the radius. I just want to constrain the distance between this point and the horizontal axis. Between that point and the horizontal axis, and I'm saying I want this distance to be 60, like that. obviously we're gonna get some errors now because we have to edit all 4 geometries, all 4 sketches. So we got sketch 2, we go to sketch 3, and we are saying this needs to be 20. I don't have a problem with the side view, so I'm going to just edit that part only. Next we've got sketch 4. So sketch 4 is a circle, and this circle we said we are reducing it to a 20mm radius, which is 40mm in diameter. And we don't have to edit sketch 5 because sketch 5 is governed by the ends of sketch 2 and 3. So we've reduced, as you can see, we've reduced that distance and this part as well. Now if you get any error or over constraint or whatever, all you have to do is edit them. So for example, here we've got an error in sketch 10. We are going to locate it, sketch 10, this one right here, and they're saying the over constraint part is length and offset. We can check that. Got this length. Okay, so I just had to delete that length and it's properly constrained now, and it has moved relative to the original geometry. Exit. Let's give it a moment to update. And now, as you can see, all our subsequent geometries have adjusted to the new diameter or the new width and height of the geometry, and that's exactly what we wanted. We wanted them to move like that. So obviously this sketch is constrained in the chassis assembly, is constrained to the friction damper assembly, and it will just move it relative to that. Now I do want to make a few changes. For example, this geometry here, pad 12. Let's go to sketch 16. So instead of a rectangle, I do want it to take on these curves. So I'm going to delete it. I'm going to delete this rectangle like that. And I want to show the sketch for pad 11. Show. And then I want to project the inner diameters. I'm going to delete this projection first. I want to project these 2 inner curves as standard elements so that they are going to be our side profile like that. And then I'm just going to add a line that is connecting them here to this end, and then I'm going to mirror it using this axis. Remember, this axis is passing through the center of these 2 circles. Or perhaps I can create my new axis so that we don't have any new constraints. Can delete that. We've got an axis passing through the centers like that. And I'm taking this line and mirroring it with this. Right, now you've got that geometry. All you have to do is trim off excess components. Trim that one off. Let me hide sketch 14 so I can see properly. So I've trimmed that and that. So now it's properly all the way up to this element and up to this element. Now the next thing we want to do is we want to move this upwards a little bit. So this is pad 11. I don't want it to exit this part. Now, one thing you need to keep in mind is that it's passing all the way through this part. You need to make sure that if you're in this, is it the side view or the front view? In this case, it's the front view. So that you need to make sure you've given an allowance here for the axle component to pass through. Alternatively, you can create this and cut it on the inside, but I'm not going to do that in this case. But you know, you can split it. You can intersect this geometry and use those curves to generate lofts or fill, and then use them to cut the geometry. But for now, I will just leave it as it is. Alternatively, if you want, you can have this component only go up to this element. Let me show you practically. The alternative is you take pad 1, and instead of having it mirrored all the way to the other side, you can say up to next, like that. And then the second one is going to be the length. Then select OK. Then we also have pad 12. Which one is it? Pocket 2. We have pad 12. It can also be up to next. Hold on. Need to check if I'm doing the right thing. I'm going to hide the drive shaft and the cap so I can check inside. We had pad 11. Pad 12. Limit 2, limit 1. So for pocket, the sketch that you're getting an error to is this full sketch. I believe so. For the no, it's this one. So we can just have, we can either first deactivate it. Can say sketch 12 and pocket 2. Hold on, delete and delete. You can show pad 11 sketch and use these two inner lines, project them like that. I'm going to hide sketch 14. So remember, the pocket was us cutting through this part right there. Okay. Then we've got pad 12. Oh, I see. Let's edit pad 12 sketch 16. Not sure what happened here, but let me redo this. This is supposed to be standard and this standard. Raise this upwards. In fact, I'm going to just constrain it so that it's not moving. Let's make it 5 and like that. trim off. That is supposed to be pad 12, not what happened. So you can have them on one side, like I said. And I'm thinking of moving it upwards a little bit. I don't like the way this is cutting through the material. Pad 11, sketch 14. I want to move it up a bit like that. So that it's not cutting through majority of the material. So like so. And perhaps this pad. Why is limit 1 on the other side? Limit 1 shouldn't be on the other side. It shouldn't cut through, but anyway, limit 2 should be somewhere closer. We shouldn't have any material inside. Okay. And then you're going to create the 2 pads on the other side. So you say create a pad using sketch 14. One is up to next. The other one is dimension 58. Reverse the direction. And I have to check that there is no material inside. Select OK. The same for sketch 16. We want the first to be up to next and the second to be 40 millimeters. Reverse the direction. Actually, we did add this. So let's do 45. Yeah, and it should be hollow like that on the inside. And now you've got them on each side, but no material is passing through where the axle and the inner components should pass. And so all you have to do is mirror these two, because as you can see, they come after the main mirror. So you have to select both of them and mirror them using the ZY axis, ZX, using the ZX axis. So they come on this side. And now you have, you can save your work. And we can go back to the assembly. You can see the adjustment. We can go back to the assembly, go to chassis assembly, and update so that the constraints update like that. And you want to check if your new geometry has cleared the leaf springs. And as you can see, we've managed to clear the leaf springs. And that is how you make adjustments on the upstream components. So it's just a matter of making sure that the subsequent geometry that come after the part you're editing are constrained to the original part. And the best way to do that is to constrain the sketches. So I hope you have learned something today. So we will now go to what we wanted to do, which was creating the U-bolts for the leaf springs at the rear section and at the front section. We can do that in our next lesson. So you're going to save your assembly, and we're going to show the drive shaft and the differential cap. And as you can see, we've managed to correct or rectify the mistake that we did earlier on. All right, that's it for today's lesson. We'll see you in the next lesson.